Professor, my dear students, and today we are going to discuss about sentimental analysis. So firstly, we need to understand the introduction of this. So I'd like to tell that the definition of sentiment analysis is it is an opinion of mining, which it particularly natural language processing (NLP) that builds systems to identify and extract subjective information from text. It aims to determine the attitude, emotions, and opinions behind a series of words. The purpose of using this sentiment analysis is the main objective is that we need to analyze text and categorize it as positive, negative, or neutral. Because of this enabling, we can say that understanding human emotions conveyed through this particular language. The importance of the sentiment analysis is with this type of this, we can explore the text data on the internet from the reviews, social media platforms, or forums, and more, etc. We can use this sentiment analysis. So it helps business and researchers which understand the public sentiment at scale of large industry. Therefore, it leads to informed decision making. How sentiment analysis works. We need to understand how it works also, right? And it properly takes the utilization techniques from NLP, text analysis, computational linguistics, and machine learning, sentiment analysis. So here the process which interprets the vast quantities of textual data available online and also from the applications. So therefore we will be monitoring the brand reputation to analyze the customer feedback and beyond. Sentiment analysis provides a very insights across the various domains. Sentiment analysis, it also interprets text to extract underlying emotions, which involves the breaking down the text into understandable segments. Therefore, we can analyze these parts of emotions, use and finally deduce the overall sentiment. And the process enables machines to understand and categorize text as expressing positive or negative or neutral sentiments. How to approach this sentiment analysis? There is a machine learning approach where in this particular method it involves training algorithms on the datasets where texts are already tagged within the sentiments positive, negative, neutral. So in this case the system learns from these examples and gives the accurate predict to the sentiment of new unseen text. As there is another method approach of lexicon based approach. This technique uses a dictionary or lexicon where words have pre-assigned sentiment scores. Text sentiment is deduced by analyzing and aggregating these scores, which provides a straightforward method for sentiment analysis. The solutions and applications where it is the highly involved. It integrates the analytical depth of machine learning with the operational efficiency of lexicon-based methods for a robust sentiment analysis framework. Therefore, in this application, adapting, analyzing customer feedback, monitoring brand sentiment, and also going public opinion across the various platforms, including social media, review sites, etc. We get also in the deep learning. In the deep learning, there is also the sentiment analysis content where it enhances that analysis by leveraging neural networks that replicate the human brain's structure and functionality. So in this approach, it allows more accurate interpretation of complex natural sentiment patterns, considering context, tone, and nuances, which leads to more precise sentimental predications that adaptively of deep learning models to various textual data forms that it effectively in interacting sentiments from diverse sources. So we need to understand challenges of our sentiment analysis. The sentiment analysis faces hurdles such as context different errors where the sentiment might change based on the surrounding text or situation. Or we can say that detecting irony and sarcasm presents a notable challenge as these can inversely imply sentiments that are opposite to the literal words used over here. Also, they can significantly alter the intended sentiment. The context-dependent error sentiment can vary significantly with context, making accurate interpretation challenging. Here, emojis. Emojis is also kind of the symbols can convey complex emotions, not easily captured by text analysis alone. So negations and idioms, the phrases that invert which are abuse, of course, the illiteral meaning can complicate the sentiment detection. Last thing is irony and sarcasm. These are the devices often imply the opposite sentiment, posing significant analytical challenges. I would like to explain through this diagram. You can see sentiment analysis has divided into 4 categories. So the first thing is content dependent errors. If we go to deep through, we use contextual analysis techniques. For example, analyzing product reviews for sentiment fluctuations based on the future context. In this scenario, emojis, second one. Emojis is the big one, one type of sentiment ranking. For example, laughing symbol is for positive and crying symbol is as negative. These are the variations present over here in emojis. While coming to the third one, negations and idioms, if we deeply go through it, implement advanced NLP parsing. For example, parsing I don't dislike, it has a positive, this kind of category. And the lastly is irony and sarcasm, where we apply machine learning with sarcasm labeling. An example, detecting sarcasm in social media posts. While coming to this sentiment analysis models and algorithms, it has leverages a range of models and algorithms which accurately interpret emotions from the text. The key models include naive Bayes, support vector machines SVM, and more advanced like RNSS and also CNSS. These are the which are the mostly 2 important key models, where we transform these models such as BERT and its variants have set new benchmarks in understanding the contextual nuances, greatly enhancing sentiment analysis accuracy. The data collection and annotation of this particular sentiment analysis is the foundation of sentiment analysis lies in gathering diverse relevant textual data from various sources like social media, reviews, and forums. In this particular, we maintain the high quality where accurately labeled data sets are crucial for training models. These are the very important over here, and they rely on this data to learn and make predictions. While the data annotations involves tagging text with sentiment labels like positive, negative, or neutral, a meticulous process that often requires human judgment. This is the important final here is human judgment. So human judgments capture the subtitles of emotions expressions. Also, we have 3 processing techniques over here. And the first thing is stemming, reduces words to their base or root form, simplifying the text and concentrating similar words for analysis. Lemmatization, more sophisticated than stemming, it involves reducing words to their dictionary form, considering the words parts of speech. The parts of speech tagging is there, which identifies each word's role in a sentence, like noun, verb, adjective, pronoun, etc., conjunction, etc., things happening. So in this particular parts of speech, it helps to understand the structure and meaning of the sentences. It also, we have tag of words, which simplistically model that represents text as frequency of words without considering order or context. We have another term called DFIDF, term frequency, inverse document frequency. This is the main thing that it weights words based on their frequency in a document, which relate to their frequency across all documents, highlighting words unique to a particular context. So last thing is word embeddings. It advanced the representation capturing semantic relationships between words which enables the models to understand context and nuance meanings. So here also I would like to explain through the form of this tree chart, where future extraction also involves here 4 steps. The first thing is transforms our text into analyzable format, and the second thing is bag of words. When you go through the bag of words, we use model that counts word frequency. For example, cat appears 3 times in a document. The third thing is TF-IDF, which is a term leads to the weight words by the importance across the documents. For example, innovation is important in a tech article, but common in a collection of patients. And the last thing is word embeddings. As we discussed, it represents words in vector space, capturing semantics. For example, king, man plus woman is close to queen. Yeah, this is the thing of understanding. And the last thing we come the evaluation matrices for sentiment analysis. We have first accuracy, which involves it is the process of measuring the percentage of predictions that the model got right suitable for particular balanced classes. The second one, precision, which indicates the proportion of positive identifications that were actually correct, crucial for scenarios where false opposites are costly. The third thing is recall. While it reflects the model's ability to find all the relevant instances, which is important when missing a positive case has serious implications. The last thing when we use F1 score, where it happens generally like harmonic mean of precision and recall, providing a balance when it's vital to consider both false positives and false negatives. So when you consider this diagram, first data collection, it goes through the process of data cleaning, then tokenization occurs. After tokenization, we go to the future extraction. Then we have model training. There we have two approaches where machine learning models or deep learning models. For example of machine learning models are naive Bayes, SVM, etc. as we discussed earlier. The examples of deep learning models are like CNNs, RNNs, transformers. They both finally come through the evaluation process and then the application continues. We also need to understand the recent advancements in our sentiment analysis. The context is the one thing where aware analysis, which make the enhancements in understanding the context within our which words are used, improving accuracy in complex text. The aspect-based analysis, which focuses on analysis in the sentiment related to the specific aspects with a text, allowing for more granular insights. Transfer learning and transformer models. Utilization of pre-trained models like sentiment analysis task, significantly reducing the training time and resource requirements while boosting their performance. The practical challenges and solutions which we face over here is in real world implementation of sentiment analysis, which encounters challenges like accurately interpreting sarcasm, which often requires deep contextual understanding, and also domain-specific languages presents hurdles due to the unique jargon and expressions using the training model, tailored models. The scalability issues arise within the large datasets and real-time analysis demands, requiring the efficient algorithms and robust infrastructure. The tools and libraries which we use for our sentiment analysis over here is NLTK, Natural Language Toolkit. This is a very comprehensive library for Python, offering easy to use interfaces for over 50 corpora and lexical resources, which along with these libraries for text processing. The Spacy is another library known for its advanced features and speed. Spacy is ideal for building applications that process and understand large volumes of context. TensorFlow, a powerful library for deep learning. TensorFlow facilitates the creation of complex models like neural networks, which are crucial for advanced sentiment analysis tasks. The integration of machine learning and deep learning has significantly advanced the sentiment analysis, enabling the development of models that can accurately predict sentiment in textual data. Along these algorithms are particularly adapted at identifying complex patterns within the large data sets. And also, these are the things like CNNs, RNNs. By using this particular models learning approach, where this patterns transfer learning is also gaining traction, allowing sentiment analysis models to improve performance on smaller datasets by leveraging pre-trained models. So as we discussed earlier about all the approaches and methods, and now we come to the conclusion of this and also we'll decide what are the future directions in our sentimental analysis. While looking forward, multimodal sentiment analysis is emerging as a key area of focus in this approach, which analyzes sentiment across different data types such as text, images, videos, and audio, which offers a more comprehensive understanding of sentiment. However, in this area we face challenges. Also, we need to be very extensive labeled datasets and sophisticated algorithms capable of analyzing various media types. Also, ethical considerations and data quality are becoming increasingly important nowadays. And these are the responsible application in sensitive domains. Maintaining high data quality is crucial for the accuracy and reliability of sentiment analysis outcomes.